Hi students, lesson 91. I'm happy to tell you that it's been thundering outside for an hour. It hasn't rained yet, but I'm really excited about all this thunder, so maybe you'll get to hear some. In the meantime, let's talk about lesson 91, linear inequalities. The title in the book is way longer and messier. I don't want to copy all that down. I don't want you to copy all that down. Linear equalities is what we're talking about. And let me just show you what they look like. I'm going to cut through some of the crazy details that the book goes into and just say that we're used to graphing things that look maybe, let me find a good example. I'll start with 91A. Section 91A on page 377. These aren't actually examples, they're diagrams in the book. We're used to graphing something that looks like y equals minus 1/2 x plus 1, for example. Okay, that's easy. You guys know how to graph that. Y-intercept, rise over the run, boom, simple, right? But what if we graph it not as an equation, but as an inequality? Okay, the only thing that's changed, boop, is that we went from an equal sign to a greater than sign. All right, this is not that hard. So the first thing that we're going to do is set out our steps for ourselves. And the first one is to graph as if it were a line. Okay, so I'm going to draw myself a nice big grid here, and I'm going to give myself a pretty big thing here. Okay, so I start with my y-intercept. I go to +1. I put 1 down. Then I see I have a negative slope, so it's going to be running downhill. So I'm going to do sink over run. I'm going to go down 1 and over 2. Okay, now before I draw the line, I know it's going to, I'm just going to well, I'm not going to pencil it in, I'm going to pen it in, but I'm going to do it lightly. Okay. If we have a choice to make here. If this inequality that we're graphing is just greater than or equal to, then we use a dotted line to mark it. Okay, let me, I have to sit funny in order to get the angle on this right. Pretend that that's straight and perfect. Okay, we use a dotted line just as when we're doing a, you know how when we're doing a number line and we don't want to include the actual point, we put a circle around it? Same strategy here. When we don't want to include the actual line, we use a dotted line. If it's a solid line, that indicates that the equal sign is part of the inequality. All right? So we find the line, then we decide if it's solid or dotted, then we use a test point to determine which side is the solution. Now, the idea here is that we're saying that we want all of the values for x and y so that the y's are always greater than that value. Okay, we don't want the ones where they're equal, and we certainly don't want the ones where y is less than. But how do we know which side shows the proper solution? Well, we use a test point, and that test point is always the origin, which is, as you know, 0, 0. All right? So we always use the origin as a test point, and it's as simple as this. We plug 0 and 0 into our equation, and we see if it comes true. So let's try our first test point. We would say 0, because that's our y value, is greater than 1/2 times x. If our x is 0, then that would be 0 plus 1. All right? This one is false. So what that tells us, right, because 0 is not greater than 1, that's false. So if the test point is false, then we choose the other side. And I'll show you what I mean by that. Here's our line. Here's the origin. We tested the origin to see if it was part of the solution, and what we found out was that it was not. If we use the origin as a test point for our inequality, we find that it's false. So the set of points that are an accurate solution are the ones on the other side of the line. Okay? If the test point would have proven itself to be true, then we would have chosen this side of the line because the test point, the origin, was true, so that means it was part of the solution. Does that make sense? Sort of, kind of? Okay, so we have graphed one equation, and now what's really cool is we can graph a second equation right on top of it, and we can find a shared solution. So let's do this. Here's our first. We'll call this one A, just like they do in the book. We've graphed A right here. Yeah. Now let's try B. B is y is less than minus, oh no, I don't want to do that. Let's find another example. All right, now that we know how to do it. Let's skip ahead a little bit. Okay. I'm skipping ahead to example 91.2. If you guys want to read all of those details, you can. I find them super confusing. I always find that when they try to explain math in words, it just is inefficient. So I don't like to do that. Y is greater than x minus 2. Y is less than or equal to x plus 1. That's the system of equations that we're going to find the graphic solution to. I draw myself a big fat grid. I number it. I'm going to go up to 5. I'm not even going to write the numbers in. All right? Y is greater than x minus 2. Remember, this would be a slope of 1 over 1. That would be 1 over 1. So first we graph it as a line. So we let's say at y is equal to minus 2 is our y-intercept. And then we have a positive slope of 1 over 1. So there it is. There's our line. I'm going to call this one A and this one B. I'm going to put an A here. Just, you don't have to do that in your homework, but it just helps keep it straight as I'm talking. And now we use the test point. Oh wait, this should be a dotted line because it does not include, it doesn't have an equal sign, so we don't include the line as part of the solution. And now we use the test point. We use the test point of the origin to see if the origin is the solution or if it's on the other side. So that would be y is greater than or equal to 1 times 0, oh no, 0 is greater than or equal to 1 times 0 minus 2. That's 0 is greater than 0 minus 2. 0 is greater than minus 2. That's true. So for line A, we want the test point of the origin to be part of the solution. And I should mention, you guys, you can use anything as the test point, but the origin is always the easiest because it's zeros, and the multiplication always works out really clean. So there's the solution to A. Now we're going to graph B. And in this one, we start at positive 1, which is here. If you have two colors, this makes this way easier. I only have one pen with me right now. So there's our point for B, and then our slope is again positive, and it's rise 1, run 1, okay? And this time we want to include the line itself as part of our solution, so I'm going to make that dark so you can see. That's our line B. Notice that they run parallel to each other, which makes sense because they have the same slope, so we would expect to see that. Now let's run a test point for line B. 0 is less than or equal to 0 plus 1. 0 is less than or equal to 1. That's true, so we want the origin to be part of the solution for line B too. So what I'm going to do is I'm going to put those lines at a little bit of an angle. So what you can see, and you can see a lot easier if you use colored stuff, is that this is the overlap right in between here. It's a solid line here, it's a dotted line here, and this region and everything in between represents the solution to this system of equations. Isn't that fun and cool? I think these are really fun problems to do. There are no more examples for you guys to do. You can jump right into the practice. I would suggest that you try to do A and B, or do, I don't know if you have the answers to B in your books. I think you do, but if not, jump down to like 7 right away and make sure you can do these before you move on and just do your homework in general. All right, it didn't thunder, but I'm excited just the same, and I hope you guys have fun with these problems. I think they're cool.